today's Leetcode daily, which says sorted GCD pair queries. I haven't solved it before. Let me reset the timer and start reading the problem. Let's see how we can approach it. Given an integer array nums, lengthen integer array queries. GCD pairs denote array calculating pairs for all the nums of I and nums of j, I less than j, and then sorting these values in ascending order. We are given queries. We need to find element at that queries of I in GCD pairs. Got it. And we need to return that array answer. Answer is the value at GCD pairs of query of I. Okay. What are the constraints? Nums.length 10 power 5, nums of I 5 into 10 power 4. Queries of I can be up to n into n minus 1 by 2. Let me think about it. Explain the problem first. We are given an array nums and we are having some queries, and for every pair I comma j, pair I less than j in nums, we need to find the GCD. Now once we get the GCD, we need to sort them. After sorting, we need to we are having some queries and we need to get the value of sorted GCD at that query index. So we are having, suppose, nums as 3 and 4. We find GCD for all the nums. GCD of 2 comma 3 is 1, GCD of 2 comma 4 is 2, GCD of 3 comma 4 is 1. Now we sort this GCD array 1 comma 1 comma 2, and once we sort, we are having some queries, so we need to find GCD at queries of I. For query 0, the output would be 1. For query 1, output would be 1. For query 2, output would be 2. So answer would be 1 comma 1 comma 2. So for the given queries, query 2 should be 2. That's all. We focus on how to find smallest GCD at second smallest GCD in the given array. So now, what would be the brute force approach you can think of? When you see all the I comma j, you would think of generating all the pairs and find the GCD, push back GCD for all the pairs, and then sort the GCD and get answer for every query and return that answer array. Right now, what would be the complexity? Suppose for the given n, it is still 10 power 5 and varies are till n into n minus 1 by 2. So if we take 10 power 5 into 10 power 5 minus 1 by 2, it is into billions. It is not optimal. So we need to forget about computing GCD for every pair and sorting it. So now just understand like what is where is the optimization we can make. Currently we are what we are doing, we are creating pairs. We are going to each pair in the nums and then generating GCD, then we are sorting and finding it. So the issue is not finding the GCD but generating in a pairs. So do we need to check each and every pair? Suppose there is a repetitive array. Suppose we have 4 comma 4. GCD of 4 comma 2 4 comma 1 4 comma 2 4 comma 1 is always same. So instead of finding GCD for all the pairs, can't we create a frequency map and find GCD for all the pairs in the frequency map? So we just need all the possible GCDs in the array, right? So 4 comma 2 4 comma 1 4 comma 2 4 comma 1, this is a repetitive pattern which does not even make sense. And GCD of 4 comma 4 is 4 itself. So there is no point of calculating GCD for the repetitive elements. So let me create map of the given nums. Now this will be reduced to 1. Now this is enough. Now instead of generating pairs, can we simply know that how many pairs have GCD1, how many pairs have GCD2, so on. If it is possible, we don't need to make a huge array. So let me think in that terms. So for every possible GCD, I need to find how many pairs can give that GCD. This feels strange. Can we same information, but what would be the final output array is the question. Suppose let me take a sorted array first. 1, 2, 5. 2, 5. Yeah. Now I have repetitive ones and twos. Now if I find GCD, it is the same 1, 1, 1, 1, 2, 5. If I store the GCD count, it would look like this. 1 is 2, 2 is 2 times, 5 is 1 time. In this way we can store the count and in ascending order manner, instead of having entire array of answer for GCD. So let me check what would be complexity of this. Suppose it is till 10 power 5 and possible values are till from 1 to 10 power 5. Now we are having map. It is so of n operation in the worst case. We are not doing any sorting. So it would be 10 power 5 operations. Yeah, this satisfies the given constraints. Can I think of any better approach, or shall we proceed with this? Now we are knowing that how many pairs have GCD 5, GCD 2 and GCD 1. Can we count them without looking every pair? We know that how many pairs have GCD K. We, instead of taking every pair to complete GCD, let me think of better approach here. Of divisibility. If like I have 12 and 18, both are divisible by 6, GCD is 6. So until all the numbers are not divisible by 6, so we can get all the numbers which will divisible by 6. So their count, suppose I have 6, 12, 18, 24. I have 4 numbers which are divisible by 6. Now to get GCD 6, I need to take pairs, any 2 pairs of this. So what would be the case, we need to choose two numbers from this 4C2. We can do combination. Wait. But GCD of 6, 12 is not 6. It is 3. Right. I missed this. It is easy to count in this divisibility way, but the GCD is not exactly the same lowest divisor. It might vary, so we need to understand key difference. GCD would be 12 for 12 and 24 pairs. Oh yes. Now suppose yeah, I understood the problem now. I have GCD 12, 24, 18, so on. Now for the given pair, I take any pair in this. Now to get the GCD, we need to include that element or exclude that element. We can't generate all the pairs, and we can't count how many pairs has this. So we need to know whether we need to include it or exclude it to get the given GCD. So this is the efficient way. So we can try reversive and inclusion exclusion. For that, I'm just thinking in terms like if I need a kth smallest or largest, can I count how many answers will be equals to value? I mean, instead of generating all the GCDs, how many answers will be equals to the GCD value? Right. So number of pairs are n into n minus 1 by 2. This will be happening for everything. So 6 has 4 divisible values. So number of things will be 4 into 4 minus 1 by 2, which is 6. This makes sense. Now why should we consider multiples is because, like, if I take 6 and 12, they both are still divisible by 2 and 3, so it gets counted with 2 also. Suppose 2, I take 4, 8, the GCD is 4. But now if I take 2, 6, the GCD is 2. Now our count contains GCD can be 2, 4, 6 and 8. Now if I want to remove that extra base, now for all the things which are divisible by 2 towards right, we find so in this way I think it is, let me think. What's the right approach? So we traverse all elements from max. What can the GCD be? Be from 1 to max value. So we traverse from 1 to max. What happens? Suppose if I want GCD as 2. Right. We can't find the GCD of the multiples of 2. We need to traverse from right to left in that case. Makes sense. Now if I move backward, I'll be having GCD of all the divisors, so I can subtract them. Now to find GCD of 2, we need to do GCD of 2 minus GCD of multiples of 2. This is simple inclusion exclusion principle. Yeah. This is the algorithm. Let me assess complexity for this. Wait. What is the complexity of this? After finding GCD, we find the counts, inclusion, exclusion, but we should also need, wait, I think I'm missing something here. I got all the GCDs. Now I need to build a sorted array. Instead of building sorted array, why I can't have a prefix count? Suppose after this I might get some GCD array like 1, 1, 2, 2, 5. Instead of like doing a sorted array, I can instead store GCD as 1, 2, 2, 1. have that index for the GCD pairs, and I can find the next possible GCD pair by doing binary search. Oh yeah, that makes sense. Now the complexity is we find all the GCD pairs which takes O of m is the maximum value, and to do binary search to find next possible pair, we need O of log m. I think it's the most optimal way. Is there any other way? Let me think. This is interesting actually. No, I don't think there is no other optimal way. So first let me find maximum value. Element of nums dot begin nums dot end. I got sorted array. I need frequency array of values are long. Let me take long. Let's see of size 0. No, I'll do frequency map into num in nums. Frequency of num plus plus. I have frequency map now. Next, what I need to do, I need to traverse from right to left for int g equals to max g greater than or equals to 0 z minus. Yeah, I traverse towards left. Oh, g can't be 0, it must be 1. Like 1 is the minimum GCD that we get here. Sorry. Now I need to get count for each pair. Initially let me take 0. Now I need to get all the devices for current G. And while k less than max, k plus equals to g, all the devices count plus equals to frequency of k. So I got count of all devices. Total pairs possible. Oh, we need one more array here to check inclusion exclusion. I'm thinking it has bounds. There might be values less than this, but in the worst case it can be till m plus mx plus 1. Now exclusion of current g will be equals to count star count minus 1 by 2. I took int any long. Yeah, now it makes sense. Now I need to do, I need to compute prefix counts, right? Yeah, I need to do cumulative count, vector of long prefix, and I need to get values at that prefix. Values. Again, I need to traverse from left to right now because I'm doing prefix. Previously I'm doing exclusion, so I traverse from right to left. If inclusion exclusion of G is greater than 0, now we are having pairs. I need some is 0, long. Now I add the inclusion exclusion to prefix sum, inclusion exclusion of G. Now prefix dot pushback of sum, and values dot push underscore back of G. Makes sense. Now the only thing I need to worry about getting for each query. Sorry, it's early in the morning, so I'm feeling some discomfort to write the code. Let's go. Long query and queries. I somehow like this problem very much. It feels lot of clear intuition for me. Prefix from the upper bound. What should be the value? Very should be the value. I need index, so I'll go with n. I think this makes sense. I just push back the value at that index. This I just return the result. Let me check the answer 1 second. Me run this max frequency max G greater than request 1. What does that mean? Oh, I took comma here, not same here. Lot of syntax issues. And we need a good sleep. I'm not excluding it, I'm just including. K is equals to Q star G and K less than MF. K plus equals to G. X of G minus equals to X of K. Now I excluded all the multiples. Now I think it would be right answer. Let me submit this. Yeah, this worked. So basically, in a simple terms, instead of finding all the pairs which is O of n square, we just optimized it to keep it bounded by focusing on divisibility. The only thing I think we need to think here is, do we need to count by value instead of pair? And this reverse sieve and inclusion exclusion would be coming by practice, and it's a great understanding why we need to include and exclude. Bye.